Hello and welcome to lesson 2-6. In this lesson, we're going to focus on how we can use modeling with math, which basically means how to show the work that we're doing. So let's go ahead and hop into our short video lesson as usual, and then we will jump into our notes and our guided practice together.
How can you represent a situation with a mathematical model? Let's look at an example. Monica wants to buy all of the art supplies shown on this sign. She has a coupon for $5.50 off the cost of her purchases. What will Monica's total cost be after the discount?
Model with math means you apply math you have learned to solve problems.
Think. What do I need to do to solve this problem? I need to find Monica's cost for the art supplies.
So in order for us to find the cost of her art supplies, we need to add up the cost of all of these items, and then we would need to figure out the difference of the total after we take away the $5 coupon that she has.
What kind of diagram would help you solve this problem? A bar diagram would help you solve this problem. Think, how can I model with math? I can use the math I know to help solve the problem. I can find and answer any hidden questions. I can use bar diagrams and equations to represent and solve this problem. What previously learned concepts and skills can you use to solve this problem? You can add and subtract decimals to solve this problem. Here's my thinking. I will use bar diagrams to represent this situation. The expression $59.95 plus $24.95 plus $9.75 plus $13.50 shows the total cost of the art supplies. The total cost before the discount is $108.15. How can you show the total amount after the discount? You can make a bar diagram with the total cost and the parts subtracted. The expression $108.15 minus $5.50 shows the total cost after the discount. Monica's cost after the discount is $102.65.
All right, let's go ahead and take a look at our notes and our guided practice for this lesson. Now, again, our lesson number is 2-6, Model with Math, and we're going to focus on the question, how can you represent a problem with bar diagrams? So first, look at each problem and list the important information that's given to you. Annotate your questions to make all of the important parts of your question stand out. Next, you want to decide what kind of operation you need to use to solve. Are they asking you to add or subtract or multiply or divide? After that, you're going to find the answer to any hidden questions in the problem. Once you've done that, you can show your work using bar diagrams to solve. Now let's take a look at our first example. At a baseball game, Sheena bought a sandwich for $6.95 and two pretzels for $2.75 each. She paid with a $20 bill. How much change did she receive? Now, what I know from this question is that she bought a sandwich for $6.95. She bought two pretzels, and each one of them cost $2.75, and she paid with a $20 bill for all of the food. Now, my first hidden question was, what was the total cost of the pretzels? And my second hidden question was, how much did the food cost in all? So to find the cost of the pretzels, we would have to do $2.75 times 2. To find the total cost of the food, I would have to take the product of $2.75 times 2 plus the $6.95 for her sandwich. So I did the $6.95 plus the product of $2.75 times 2, which gave me $6.95 plus $5.50, which gave me a total of $12.45 for all of her food. Now, to solve my original question, I'm going to write it out as an equation with 20 minus the sum of $6.95 plus the product of $2.75 times 2. That's going to give me 20 minus the $12.45. Now I can draw that using a bar diagram, and I can also stack and subtract. So using a bar diagram, we know the $20 is going on top, the $6.95 and the $2.75 and the other $2.75 is going to go on the bottom, plus whatever she's going to get for change. All of that needs to equal $20. So I stacked and subtracted, and I found that my difference was $7.55 in change. Now I checked my work by doing the inverse operation, and I added all of those parts back together. The $7.55 in change, plus the $2.75 for the first pretzel, the $2.75 for the second pretzel, and the $6.95 for the sandwich did in fact give me a total of $20. Let's take a look at our next example. Alberto ran 15.6 kilometers on Monday, 12.8 kilometers on Tuesday, and 6.5 kilometers on Wednesday. Dennis ran 11.25 kilometers on Monday, 14.6 kilometers on Tuesday, and 8 kilometers on Wednesday. Who ran farther and how much farther? So first I need to figure out what I know. I know that Alberto ran 15.6, 12.8, and 6.5 kilometers. Dennis ran 11.25, 14.6, and 8 kilometers. Now my hidden question is how far did each of them run in all? So I created 2 bar diagrams. Alberto is on the left. I filled in his times, his distance runs, 15.6, 12.8, and 6.5. I did the same thing for Dennis on the right side. Now then, for Alberto, I stacked and added. So I lined up the place values and I lined up the decimal points. 6 plus 8 plus 5 gave me a total of 19. I put my 9 and I carried my 1. I dropped my decimal point. The 1 plus the 5 plus 2 plus 6 gave me 14. I put my 4 and carried my 1, and then the 1 plus the other 1 gave me 3. So I know Alberto ran a total of 34.9 kilometers, or 34 9/10 of a kilometer. Now to find the total distance run for Dennis, I lined up his numbers as well, 11 25/100 plus 14 6/10 plus 8. And then I stacked and added. So I put in 0 placeholders for the place values that had nothing in them for my decimals. So 5 plus nothing plus another nothing gave me 5. 2 plus 6 gave me 8. I dropped that decimal point down into its place. 1 plus 4 plus 8 gave me 13. I put my 3 and carried my 1. And then the 1 plus another 1 gave me 3. So Dennis's total distance was 33 85/100. Now I need to find out who ran farther and how much farther. So I'm going to take Alberto's, which was a greater distance. So we know Alberto ran farther because his distance was 34 9/10 of a kilometer, and Dennis was 33 85/100 of a kilometer. So I stacked and subtracted. I put in my 0 placeholder to do my subtraction. Nothing minus 5, I can't do that. So 10, that 0 became a 10 because I borrowed from the 9 next to it. So that 9 became an 8. 10 minus 5 is 5. 8 minus 8 was 0. Dropped my decimal point. 4 minus 3 was 1. And then 3 minus 3 was 0. So to answer the question, Alberto ran farther by 1 5/100 of a kilometer than Dennis. For our guided practice, our first question, or our questions are both based on the same problem. Nate has $30.50.
He wants to buy his dog a sweater that costs $15, a toy that costs $3.79, and a leash that costs $14.79. How much more money does he need? So what the first question asks, what do you need to find before you can solve the problem? So what are the hidden questions? Now I know I need to calculate the total cost of all the items he wants to buy. So I drew, for number 2, it says draw a bar diagram to represent the problem and then solve. Show the equations that you use to solve. So for the first one, I wanted to find T, the total cost of the items that he wanted to buy. So I drew my bar diagram. I know he wanted the sweater for $15, the toy for $3.79, and the leash for $14.79. So I added those together, and it came up for a grand total of $33.58 is the total cost of the things he wants to buy. Now, we know that he has $30.50. So we put the total cost on top in a new bar diagram. That's our total. One of the parts is the money that he has, $30.50. And the other part we don't know is going to be M, the money that he still needs. So in order to find that, we're going to take our total of $33.58. We're going to subtract from it the $30.50. And you can see I stacked and subtracted here on the bottom right. And it came up for a difference of $3.08. So Nate needs another $3.08 to be able to buy all of the things that he wants to buy for his dog. That's it for this lesson. If you have any questions, let me know. Otherwise, have a great day. Bye-bye.